I hope all of you are doing good. Let's start today's chapter, Factors and Multiples. Introduction. In our previous classes, we have studied the basic ideas about factors, multiples, prime and composite numbers. In this chapter, we shall review these concepts and properties related to them and extend our study to include some new properties. We shall also study in more detail the concept of lowest common multiple, that is LCM, and highest common factors, that is HCF. Throughout this chapter, we shall be concerned with the natural numbers. In this chapter, the term number means a natural number. Remember that, okay? Factors and multiples. Factors. A factor of a number is a number which completely divides a first number, leaving the remainder as 0. In other words, a factor of a number is an exact divisor of that number. Okay, example, consider the number 15. We can say 1, 3, 5 and 15 are factors of 15 because they divide 15 exactly, leaving remainder as 0. However, 4 is not a factor of 15. When divided, it leaves a remainder 3. Consider the number 16, 1, 2, 4, 8 and 16 are its factors. From the above examples, we find that 1 is a factor of every number. The number is a factor of itself. Number 3, 1 is the only number which has exactly one factor, namely itself. Multiples. A multiple of a number is a number obtained by multiplying by a natural number. Consider any natural number, say 5. Multiplying 5 with the numbers 1, 2, 3, we get 5, 10, 15, 20 and so on. So, all these are multiples of 5. Similarly, numbers. These numbers are multiples of what? Of which number? 6. From the above definitions of factors and multiples, it follows that number 1, if a number x divides a number y exactly, then x is called a factor of y and y is called a multiple of x. Number 2, if x is a factor of y and y is a factor of x, then x is equals to y. Okay. Example, find all multiples of 15 up to 100. Okay, so write 15, table of 15. First multiple is 15, 15 into 2 is 230, third multiple is 45, then 60, 79. Okay, we have to write only up to 100. Okay, so these are the multiples of 15 up to 100. Factors of 32 are 32 is equals to 1 into 32, 2 into 16 is equals to 4 into 8. Hence 1, 2, 4, 8, 16 and 32 are factors of 32. Now, prime and composite numbers. In the previous class, we have seen that every natural number other than 1 has at least 2 factors, namely 1 and the natural number. We can classify the natural numbers into the following groups. Number 1, numbers having exactly one factor, for example 1. Number 2, numbers having exactly 2 factors, for example 2, 5, 7, 11, 13, etc. 3, numbers having more than 2 factors, for example 4, 6, 9, 10, etc. So, we define prime and composite numbers as follows. Prime number. A number is called a prime number if it has no factor other than 1 and the number itself. Examples are, these numbers have exactly 2 factors, namely 1 and the number themselves. Number 2 is composite number. A number is called a composite number if it has more than 2 factors. Example, each of the numbers, that is 4, 6, 8, 9, 10, etc. have more than 2 factors. Such numbers are called composite numbers. Some facts about prime and composite number. The number 1 is neither prime nor composite, 2 is the smallest prime number and 2 is the only even prime number, all other even numbers are composite. 4, if a number is not divisible by any one of the prime numbers, less than half of it, then it is a prime number. Otherwise, it is a composite number. 5, the number of primes is infinite and there is no largest prime number. 6, every natural number other than 1 is either prime or composite. Okay. The sieve of Eratosthenes. The famous Greek mathematician Eratosthenes found a simple method for finding prime and composite numbers in the 3rd century BC. The method is known as the sieve of Eratosthenes. We illustrate this method for natural numbers 1 to 100. The following steps are used to find prime and composite number between 1 and 100. Step 1. First, prepare a table of numbers 1 to 100. Then step 2, cross out 1 as it is neither prime nor composite. Step 3, encircle 2 and cross out all its multiples. Step 4, encircle 3 and cross all its multiples. Ignore crossed out numbers, that is 4, 6, 8, 9, etc. Step 5. Continue this process of encircling the next uncrossed number and crossing out its multiples until all the numbers in the list are either encircled or crossed. Step 6. List all encircled numbers as prime numbers and all crossed out numbers as composite number. Ignore 1. Then from the above chart, as you can see here, we note that these are prime numbers and all others are composite numbers except for one which is neither prime nor composite. Okay, let's learn about some more definition. First is twin primes. Two prime numbers are known as twin primes if there is only one composite number between them. Pairs of twin primes between 1 and hundreds are given. Okay, prime triplets. A set of 3 consecutive prime numbers differing by 2 is called a prime triplet. Okay, the only prime triplet is this 3, 5, 7. 5, difference of 5 and 3 is 2 and difference of 7 and 5 is also 2. Okay, next co-primes, and remember this is the only prime triplet. Okay, co-primes. Two numbers are said to be co-prime if they don't have a common factor other than 1. Example, all these are pairs of co-primes, right? Properties of factors and multiples. Property 1. If A is a factor of B and C is a factor of C, then A is a factor of C. 4 is a factor of 8 and 8 is a factor of 16. Obviously, 4 is a factor of 16. Okay. 2. If P and Q are primes and numbers and both are factors of a number A, then the product P and Q is also a factor of A. For example, number 70. Its prime factors are 2, 5 and 7. 2 into 5 is 10, 5 into 7 is 35 and 2 into 7 is equal to 14 are also factors of 70. Okay. Property 3. If A is a factor of two numbers B and C, then A is a factor of their sum B plus C. Example, if 3 is a factor of 9 and 12, hence 3 is also a factor of 9 plus 12, that is 21. Similarly, if 4 is a factor of 12 and 36, it is a factor of 12 plus 36, that is 48. Okay. Property 4. If A is a factor of two numbers B and C, then it is a factor of B minus C also. Thus, 6 is a factor of both 12 and 36. It is a factor of 36 minus 12, 24. Similarly, since 11 is a factor of 77 and 121, it is also a factor of 121 minus 77, that is 44. Okay. So, these two properties are quite interesting, isn't it? Exercise 3.1. Write all the factors of 13. Okay, write down factors of 13. So, 13 have only two factors, 1 and 13. Okay. Next, test for divisibility. We know that composite numbers are divisible by smaller numbers. To see if a number is divisible by another number, normally we perform the actual divisions. However, in certain cases, we can find out the possibility of division by certain tests. Following are some such tests. Many of them we have studied in earlier classes. Number 1, divisibility by 2. A number is divisible by 2 if its units place is divisible by 2. Okay. See, example 8, there is 0, 6, then 2, then 4. We will just only look at the units place. Okay. So, all these numbers are divisible by 2 since their unit places are divisible by 2. However, these numbers are not divisible by 2 because their unit places are not divisible by 2. Okay. Number 2, divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. For example, 183. 1 plus 8 plus 3. 1 plus 8, 9 plus 3 is 12. 12 is divisible by 3. Therefore, 183 is also divisible by 3. Okay. Divisibility by 4. A number is divisible by 4 if the number formed by digits in tens and units place is divisible by 4. That is first two digit from the right. Okay. For example, this number. Okay. Digits at units and tens place is 48. 48 is divisible by 4. That means this whole number is also divisible by 4. Okay. However, here is this number given which is not divisible by 4. Next, divisibility by 5. A number is divisible by 5 if its unit's digit is a 0 or a 5. Okay, means 15, 40, 85, 70, all these numbers are divisible by 5. Next, divisibility by 6. A number is divisible by 6 if it is divisible by both 3 and 2. Consider this number 4272. Okay, unit digit is 2, that means it is divisible by 2. Okay, now let's find the sum of the digit. 4 plus 2 plus 7 plus 2. 4 plus 2, 6, 6 plus 7, 13 plus 2 is 15. 15 is divisible by 3, that means this number is also divisible by 3. Now, this number is divisible by both 2 and 3, that means it is also divisible by 6. Okay. Next, divisibility by 8. A number is divisible by 8 if the number formed by the last 3 digit is divisible by 8. For example, you have this number 56,712. We will consider these 3 digits. If this number is divisible by 8, then this number will also be divisible by 8. Okay. So, by dividing we will find out. Okay. 8 8s are 64. 11 minus 4 is 7, 2, 89. Okay. That means this number is divisible by 8. Next, divisibility by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. For example, 37062. Okay. Three 37062. 3 plus 7 plus 0 plus 6 plus 2. 3 plus 7, 10, 10 plus 6, 16, plus 2 is 18. 18 is divisible by 9, that means this number is also divisible by 9. Okay. 8. Divisibility by 10. A number is divisible by 10 if its unit digit is 0. Okay. Divisibility by 11. A number is divisible by 11 if the difference of the sum of its digit in odd places and the sum of digits in even places is either 0 or a multiple of 11. Okay. So, example is this 179278. Okay. Sum of digits at odd places. Okay. Odd 1, 8, 2 and now means first place 1, 2, 3, 4, 5, 6. So, this is odd place. Okay. So, sum of odd place, sum of digits at odd place. Okay. Sum of digits at odd place. Okay. Is 8 plus 2 plus 7. 8 plus 2 is 10 plus 7 is 17. Now, remaining digits are digits at even place. Okay. Now, sum of digits at even place. 1 plus 9 plus 7. 1 plus 9 is 10 plus 7 is 17. Now, difference of these is what? 17 minus 17 is what? 0. That means this is divisible by 11. Okay. General properties of divisibility. Property 1. If A, B, C are 3 natural numbers such that A is divisible by B and B is divisible by C, then A is also divisible by C. Okay. Verification. 36 is divisible by 6 and 6 is divisible by 3 and 2. Hence, 36 is divisible by 3 and 2 also. Okay. Property 2. If A and B are 2 co-prime numbers such that a number C is divisible by both A and C, then C is also divisible by A into B. For example, 35 is divisible by 5 and 7. It is also divisible by 5 into 7 is equals to 35. Okay. Property 3. If two numbers B and C are divisible by a number A, then B plus C is also divisible by A. For example, 25 and 45 both are divisible by 5. Their sum is also divisible by 5. And property 4, if two numbers B and C are divisible by number A, then B minus C is also divisible by A. For example, 183 and 6 654, these are divisible by 3, and their difference 471 is also divisible by 3. Okay. Exercise 3.2, test the divisibility of the following by number 2. Okay, we just have to look at the unit place. Okay, here is 0, so it is divisible by 2. Here 5, not divisible by 2. At unit place it's 8, it is divisible by 2. And here at unit place it's 7, so not divisible by 2. Okay. Prime factorization. We have seen that numbers can be prime or composite. If a number is composite, we can write it as the product of 2 or more numbers. These numbers could be prime or composite, which can be further factorized. Thus, we can express any composite number as a product of prime numbers. The following example shows the prime factorization of 36. See, in both the cases, it's equal. So, and this process is also represented by the following method. Okay, so the process of expressing a given number as a product of prime factors is called prime factorization, or simply complete factorization of the given number. Okay, exercise 3.3, we have to find the prime factors of the following: 49, 7 into 7. So 49 is equals to 7 into 7, or you can also find like this: 7 into 7, 49, 7 ones are 7. Okay. So 49 is equals to 7 into 7, right? Highest common factor. Earlier in this chapter, we have seen about factors and multiples of given numbers. In this section, we shall see how to compare factors of groups of numbers and find the largest that is common to them. The highest common factor of 2 or more numbers is a number which is the greatest among their common factors. HCF is also known as the greatest common divisor. There are two commonly used methods for finding the HCF of 2 or more numbers. They are prime factorization method and the continued division method. Prime factorization method. To find the HCF of 2 or more numbers by prime factorization, we first find the prime factor of each number and find the highest common factor. For example, we have to find the HCF of 144 and 200. Okay, see. Now, HCF of 144 and 200 is what? 2 into 2 into 2 into is equals to 8. Okay. Now, to find HCF by continued division method. Okay. In this method, we divide the larger number by the smaller number. We get a remainder. Then we divide the first divisor by the remainder, getting a new remainder. We continue this process till we get 0 as remainder. The last divisor is the required HCF of the given number. For example, we have to find the HCF of 144 and 204 by division method. Okay. So, we will divide 204 by 144. So, 144 ones are 144. 4 minus 4 0, 10 minus 4 is 6. Now, this remainder will become the divisor and the dividend will become, and the divisor will become the dividend. 62s are 120, 4 and 2. Now, this will become the divisor, okay, and this divisor will become the dividend. 24 2s are 48. 10 minus 8 is 2, 5 minus 4 is 1. 12 becomes the divisor and here 24 will become the dividend. 12 2s are 24, okay. So, the HCF is what? 12, okay. To find HCF of more than 2 numbers, we proceed as follows. First, find HCF of any 2 numbers. Third, we find the HCF of this result and the third number. For example, we have to find the HCF of these 2 numbers. First, these 3 numbers. First, we will find HCF of 120 and 144, which is 24. Now, we will divide this number by 24, okay, and then here 12. So, 12 is the HCF of these 3 numbers, right? Exercise 3.4. Find the HCF of the following by prime factorization method. Okay, let's find out. 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6 and 3 1s are 3. Next, we have 36. 2 1s are 2, 2 8s are 16, right? 2 9s are 18, 3 3s are 9, 3 1s are 3. Okay, so what is the HCF? 1, 2, then again common, then 3. So 2 into 2, 4 into 3 is 12. So 12 is the HCF of 24 and 36. Okay. Lowest common multiple, that is LCM. The lowest common multiple of 2 or more is a number which is a common multiple of the numbers and is the smallest among all common multiples. For example, 12 and 24, multiples of 12 are given here, multiples of 24 are given here. So the lowest common multiple of both is what? 24. Okay. There are two methods which are usually employed to find the LCM of given numbers. They are prime factorization method and a common division method. First is a prime factorization method. In this method, we find the prime factors of each number and express those in exponential form, that is powers of primes. We take the product of each prime factors with the highest power to calculate the LCM. Okay. For example, 40 is equals to 2 into 2 into 2 into 5. So 2 raised to the power 3 into 5. 48 is equals to 2 raised to the power 4 into 3. And 64 is 2 raised to the power 6. So we will take highest power of 2, that is 2 raised to the power 6. Then 5 into 3 and 960, this is the LCM. Okay. And common division method, to find LCM of numbers with this method we adopt the following procedure. Number 1, write all numbers in a row separated by commas. 2, choose the least prime number which divides at least one of the numbers. 3, divide each given number by this prime number and write the quotient below the given numbers in the second row. The numbers which are not divisible by the prime numbers are carried over to the second row as such. For repeat steps 2 and 3 with the second row and form the third row. Continue this process till the numbers in a row are all 1. 5. The product of all the prime divisors is the required LCM. For example, we have to find the LCM of 15, 20, 25 and 30. Okay. So first we will divide by 2. Okay. 15 cannot be completely divided by 2, so we will write 15 as it is. Then 10, 25 and 15. Right. 2. We will write 15 as it is, here 5 because 2 5s are 10, write 25 as it is, 15 as it is. Now start dividing by 3. 3 5s are 15, we will write 5 as it is, 25 as it is and 3 5s are 15. Now start dividing by 5, 5 1s are 5, 5 1s are 5, 5 5s are 25, 5 1s are 5. Now 5, 1, 1, 1, 1. Now we will multiply all these numbers. LCM is equals to 2 into 2 into 3 into 5 into 5. 2 into 2, 4, 4 into 12 into 5 into 5 is 25 and 25 into 12 is what? 25 2s are 50, 5 carry, 25 1s are 25 plus 5 is 30. So 300 is the LCM. Okay. Some properties of the HCF and LCM. The HCF of the given numbers is not greater than any of the numbers. Remember that. The LCM of the given numbers is not less than any of the given numbers. 3. The LCM of 2 or more co-prime numbers is equal to their product. 4. The HCF of 2 co-prime numbers is 1. 5. If a number x is a factor of another number y, then the HCF of x and y is x and LCM is y. 6. The HCF of given numbers is always a factor of their LCM. 7. The product of the HCF and LCM of two numbers is equal to the product of the given numbers. Thus, if A and B are two numbers, we have A into B is equals to HCF into LCM. Okay. Exercise 3.5. Determine the LCM of numbers in each of the following. Okay. Let's find out the LCM of 48 and 64. 2 2s are 4, 2 4s are 8. 2 3s are 6, 2 2s are 4. 2 12 and here you will write 16. 2 6 are 12, 2 8s are 16. 2 3s are 6, 2 4s are 8. 2 2s are 4. 2 1s are 2, now 3. 3 1s are 3. Now LCM is what? 2 into 2 into 2 into 2, then 2 into 2 into 3. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 and 32s are 64 into 3. 3 4s are 12, 3 6 are 18 plus 1 90. So 192 is the LCM. Okay. Learning outcomes. A number which divides a given number exactly is called a factor of the given number. 2. A multiple of a number is exactly divisible by the number. 3. Every number is a factor as well as a multiple of itself. 4. 1 is the factor of every number and it is neither prime nor composite. 5. 2 is the only prime number. Okay. 6. Prime factorization of a number is unique. 7. A number is divisible by 2 if the unit digit of the number is 0, 2, 4, 6 and 8. 3. If the sum of the digit is divisible by 3. And a number is divisible by 4 if the number formed by its tens and units place is divisible by 4. A number is divisible by 5 if its units digit is 0 or 5. And a number is divisible by 6 if it is divisible by 2 and 3. 8 if the number formed by its 100 tens and units places is divisible by 8. 9 if the sum of its digit is divisible by 9. 10 if the unit digit is 0. And 11 if the difference of the sum of its digit in odd places and the sum of digits in even places is either 0 or divisible by 11. Okay. 8. The HCF of 2 or more numbers is the largest number that divides all the given numbers. 9. The LCM of 2 or more numbers is the smallest number which is divisible by all the given numbers. 10. The product of HCF and LCM of two numbers equals their product. This result may not be true for more than two numbers. 11. The HCF of any two prime or co-prime numbers equals to 1. 12. The LCM of any two prime or co-prime numbers equals to their product. 13. The HCF of two or more numbers is never greater than any of the numbers. 14. The LCM of two or more numbers is never less than any of the numbers. 15. The HCF of two or more numbers is a factor of their LCM. And 16. If x is a factor of y, then HCF of x and y is x and the LCM of x and y is y. Okay, students, I hope you have understood this chapter and now you will do practice of the remaining questions.